In this video, I want to revisit the roots of unity. The roots of unity, namely the nth roots of unity, are the solutions to the complex equation z to the n equals 1. We talked about the fact that this means that these points are on the circle of radius 1 centered at the origin, if we want to call it the unit circle. And we know that these are the n equally spaced points, starting with, of course, z equals 1 is a solution. And then if we were to have the circle of radius 0, then the equally spaced n points around there would be the nth roots of unity. Now, we can write these a little bit nicer. Those are not equally spaced, but just pretend with me. So we can write these a little bit nicer since we know that if z is r e to the I theta, and r is 1, that means that all of our solutions are going to be the values e to the I theta, where theta is between 0 and 2 pi. In fact, let's get rid of 2 pi to get rid of the ambiguity. So theta is between 0 and 2 pi. And then we want to look at z to the n equals 1. Well, we know that z to the n is just e to the I theta n. And that's going to be equal to 1 if theta n is equal to some multiple of 2 pi, right? If theta n is equal to some integer multiple of 2 pi. So if it's 2 pi k for some k. And so what this means is that if theta is 2 pi k over n, then we get a root of unity. In other words, putting all of this together, the roots of unity, the nth roots of unity, are going to be the values e to the I theta, where theta is 2 pi k over n. And here, these are going to be unique values in the interval from 0 to 2 pi whenever k is between 0 and n minus 1. Okay, so as soon as we get to k equals n, then you get theta equals 2 pi, and then you've kind of repeated yourself. So we get unique values just from k equals 0 to k equals n minus 1. But this tells us right away that we know exactly what the roots of unity are. So for example, we could find the fourth roots of unity, which we already know, of course, are plus or minus 1, plus or minus I. But just to make sure that this works out, we would get that the fourth roots of unity are going to be e to the I times, we can actually write all of this in the exponent if we want, 2 pi I k over 4, where k goes between 0 and 3 inclusively. And let's just check that. Of course, if k is equal to 0, then e to the 2 pi I 0 over 4 is just 1. Great. If k is equal to 1, then e to the 2 pi I over 4 is e to the I times pi over 2. And then that's going to be what would be kind of the north pole of the circle. So in other words, the point I, right? This is, if we wanted to write it out, cosine of pi over 2 plus I sine of pi over 2. Cosine of pi over 2 being 0, sine of pi over 2 being 1. So this is just I. And you can just check the other two, that when k equals 2, you get e to the, let's see, what would it be? 2 pi I times 3 over 4. And that would be minus 1. And then when k is equal to 3, you get e to the 2 pi I. Oops, that should be a 2. So when k is equal to 3, you'll get minus I. Okay, so I'll let you check those last two, but this is how the roots of unity work in general. And now we know exactly what the roots of unity are. We don't really have to do too much work. So just as a question for you, let's find the fifth roots of unity. So I want you to find the fifth roots of unity. Of course, z equals 1 is going to be one of them, and then we'll have 4 more, but I want you to write them out and see exactly what they are.